Welcome to Manohar Chemistry YouTube channel. Today I am going to explain classification of elements. In that, what is the need of classification first? So classification will give clarity for you people. Elements will come under metals, and which elements are come under non-metals, and which elements can come under gaseous state. Which elements will come under gases. So if we know the physical state of any element, if we know the physical state of any element, then we can predict its properties very easily. If you know the physical state of element, then we can predict its chemical properties as well as physical properties too. So that here nearly 118 elements are there. These 118 elements are classified into 4 blocks based on its electronic configuration: S block, P block, D block and F block. So how can we classify these 118 elements into 4 blocks? So here electronic configuration is a main criteria. In that, in electronic configuration, they followed differentiating electron is one criteria. Based on differentiating electron, these 118 elements are classified into 4 blocks. That is S block, P block, D block and F block. Definition of S block elements. In which elements differentiating electron present in valency shell of s orbital. Valency shell of s orbital. Such type of elements come under S block. So here we know that s orbital can accommodate only 2 electrons. So that's why S block elements are classified into 2 groups, that is first A group elements and second A group elements. In first A group elements, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So here hydrogen is a gas, remaining all elements are metals. Hydrogen is a gas. But here why hydrogen kept in first A group elements? Just you see their electronic configuration. In case of hydrogen, that is 1s1. So in case of lithium, that is helium 2s1. So by using inert gas electronic configuration, we can represent electronic configuration of all elements in short form like this. So lithium, so helium 2s1, sodium, neon 3s1. Similarly 4s1, 5s1, 6s1, 7s1 will come. So just you observe valency electronic configuration of these first A group elements. In that, all elements having 1 electron in its valency shell. So that's why because of this reason, remaining elements which are present in first A group elements. So because of electronic configuration similarity, because of valency electronic configuration similarity, so this hydrogen kept in first A group elements. So now these first A group elements are called alkali metals. So actually alkali stands for base actually. So these first A group elements, oxides, when they are reacting with water, they will form bases. So base we call it as alkali. So that's why we call them as what? Alkali metals. So for example here sodium oxide is there. When sodium oxide is reacting with water, then it is going to form sodium hydroxide, which is base. So when metal oxides reacting with water, they will form bases. Because of this reason, these are called what? Alkali metals. And second A group elements, when you go for second A group elements, so beryllium, magnesium, calcium, strontium, barium and radium. So just you see these elements electronic configuration. So these all having in valency shell, these second A group elements having NH2 as a general electronic configuration. Why? Because these all elements having 2 electrons in its valency shell. These second group elements are called alkaline earth metals. Why? Because these oxides also will form bases when they are reacting with water, and these elements are available in earth crust. So that's why we call them as a alkaline earth metals. And here these all elements are metals except hydrogen. These all elements, first A group elements and second A group elements are metals. So that's why they are always willing to form ionic compounds except lithium and beryllium. So these lithium and beryllium will prefer only covalent compounds. Why? Because of small size. These lithium and beryllium always willing to form covalent compounds. Other than that, except lithium and beryllium, all elements are willing to form ionic compounds. For example, which is very familiar compound, that is sodium chloride, table salt we can say. This table salt is a attraction force between sodium cation and chloride anion. So it is very familiar example, and these all are metals. So that's why they are willing to form, every time they are willing to form ionic compounds only, right? And they are very soft metals, and these elements are willing to release electrons. Metallic nature is nothing but willing to lose electrons easily. When these metals are willing to lose electrons easily, these elements undergo oxidation. Oxidation is nothing but what? Increasing in oxidation number. So for example, sodium is there. Sodium will lose one electron and it will form Na plus. By losing one electron, it will form cation. Means it undergoes oxidation. If another element, for example chlorine is there, chlorine will accept one electron and it undergoes reduction. Means chlorine oxidation number 0 to minus 1 means decreasing. Sodium oxidation number 0 to plus 1 means increasing. Sodium undergoes oxidation and chlorine undergoes reduction. So because of whom chlorine undergoes reduction? Because of sodium. Because of sodium, chlorine undergoes reduction. So sodium is responsible for the reduction of chlorine. So that's why here sodium is called what? Reducing agent. Not only sodium, the elements which are present in this first A group elements, they will act as a best reducing agents. But we know that reducing agents will undergo oxidation. Reducing agents undergo oxidation, but they are responsible for the reduction. And these are having low melting point and low boiling point, and they will show characteristic colors when we introduce these elements into the Bunsen burner. When we are introduced these elements in Bunsen burner, they will show different type of colors. For example, calcium we are taking. When we introduce calcium element in a Bunsen burner, it will show brick red color. So this is one of the example for the characteristic of the flames. So now, then after black elements. So in which elements differentiating electron enter into the p valency shell, such type of elements will come under p black elements. So just you take carbon as an example here. So carbon electronic configuration is 1s2, 2s2 and 2p2. So just you observe in the carbon electronic configuration, the sixth electron present in valency shell. Sixth electron is a differentiating electron. That sixth electron present in valency shell. So that's why differentiating electron enter into p orbital. So that's why carbon will come under p black element. So we know that p orbitals can accommodate 6 electrons easily. So that's why in case of p black, there are 6 groups will be there. That is boron family, carbon family, nitrogen family, oxygen family and fluorine family and helium family. So there are 6 groups are there. Now we are going to discuss one by one. So before going to discuss these groups in a p black elements, I would like to introduce one small concept here. So just you observe helium element. Helium atomic number is 2, right? So its electronic configuration is 1s2. So according to the black definition, according to S black definition, so in which elements differentiating electron present in s orbital, valency shell s orbital, then that element has to present in s black. But in case of helium, differentiating electron present in s orbital, but you see in a periodic table, helium is present in p black. Then what is the reason behind this? Just here there is no special reason, only because of inertness of helium. Helium is kept along with inert gases, because inert gases also having inertness as well as helium also having inertness. Because of similarity in inertness, helium is present along with the 0 group elements, that is neon, argon, krypton, xenon and radon. So then now we are going to discuss each and every group which are present in p black. Just you see in boron family, there are in case of boron family, boron, aluminum, gallium, indium and thallium. Just you see these elements general electronic configuration. So boron atomic number is 5. Just you go for electronic configuration, that is 1s2, 2s2 and 2p1. So there are boron, aluminum, and aluminum atomic number is 13. Just you go for electronic configuration of this one, that is neon 3s2, 3p1. By using inert gases, we can express electronic configuration in short. We can expand as well as we can compress electronic configuration. Boron, that is helium 2s2, 2p1 will come. Helium 2s2, 2p1. In case of aluminum, that is neon 3s2, 3p1. Then after 4s2, 4p1, 5s2, 5p1. So 6s2, 6p1 will come. So just you observe these all elements. In these all elements, so what is similarity in these all elements? ns2 np1 is a similarity, means valency shell electronic configuration is same. Because of that valency electronic configuration similarity, these all elements present in one group. If valency electronic configuration is different, then these all elements cannot adjust in one group. So because of that similarity only, these all elements are arranged in one group. We are discussing exclusively classification based on electronic configuration. So this is one similarity. So this third group elements having general electronic configuration is ns2 np1. So because of this reason, these elements valency will become 3. So means these elements are willing to form 3 bonds only. Just you see here BH3, boron, BH3 is there, and BCl3, AlCl3. Everywhere these type of elements will form only 3 as only 3 bonds. So that's why we call them, these elements valency will become 3. So and these elements hydrates also behave as a electron deficient compounds. Why? Because here for these elements octet is not completed. Just you see BCl3. So in case of BCl3, around the boron 3 chlorines are there. 3 chlorines means then how many bond pairs are there? There are 6 electrons are there. Means 3 bond pairs means 6 electrons, which is not completed its octet. So it is try to get octet so that it will act as a electron deficient compound. We know that Lewis acids also, these group elements are act as a Lewis acids also. These group halides will act as a Lewis acids because of deficiency of electrons. Then next group is carbon. So carbon family. In carbon family, carbon, silicon, germanium, tin and lead. Carbon, silicon, germanium, tin and lead. So these elements general electronic configuration is NS2 NP2. Why? Because just you see these all electronic configuration. For in case of carbon 2s2 2p2, in case of silicon 3s2 3p2, in case of germanium 4s2 4p2, in case of tin 5s2 5p2, in case of lead 6s2 6p2. Okay, so this is general electronic configuration. By using inert gases we can write in short form. So just you observe the valency shell electronic configuration of all these elements, that is NS2 NP2. So simply we can say that these carbon group elements valency will become 4, means CCl4, CH4. So these always willing to form 4 bonds. Here some special character is there for carbon, so that because of that reason carbon chemistry will exist. Carbon chemistry is existing nowadays. So that what is the reason behind that? So why there are 118 elements are there, but here exclusively carbon chemistry is existing, other chemistries are not there. Means every element doesn't have its own chemistry, but carbon has its own chemistry, that is organic chemistry, right? So why? Because there are 2 reasons are there. One is tetravalency and another one is catenation capacity. So I will explain in upcoming classes what is tetravalency and what is catenation capacity. So next I am going to explain the 5th group. So in 5th group, nitrogen, phosphorus, arsenic, antimony and bismuth. These 5th group elements are called nicogens. These 5th group elements, general name for these elements are nicogens, and these all elements having 5 electrons in its valence shell. In nitrogen you see 1s2 2s2 2p3. 2s2 2p3 is the valence electronic configuration. Remaining elements neon 3s2 3p3, 4s2 4p3, 5s2 5p3, like that it will come. Just you observe the electronic configuration of all these elements, they are having 5 electrons in its valency shell. So means, so here the valency of these elements, some of the elements will exhibit 3 and some of the elements will exhibit 5 also. In case of nitrogen, it can show only 3 trivalency. Nitrogen can show, remaining elements will show up to pentavalency. Why? Because in case of nitrogen, d orbitals are not available. Lack of d orbitals, nitrogen will not extend its valency up to 5. But in case of phosphorus, arsenic, antimony, bismuth, elements will show 5 valency. Why? Because these are in these elements d orbitals are available. So next group is oxygen family. Oxygen, sulfur, selenium, tellurium and polonium. Just you see these general electronic configuration of these group elements is NS2 NP4 will come. Why? Because each and every element is having 6 electrons in its valency shell. 2s2 2p4, 3s2 3p4, 4s2 4p4 and 5s2 5p4. So remaining elements also having this type of electronic configuration. They will show 2 valency, means these elements are by taking 2 electrons they will approach octet, so that's why they will show 2 as its valency, and these oxygen family group elements are called chalcogens. Okay, so why? Because they are having, chalcogens means ore forming elements. So why we call them as a ore forming elements? Maximum ores are being with oxygen. So for example, Al2O3 is a ore of bauxite which is having oxygen. Lead oxide also one of the ore for the lead which is having oxygen in its structure. So thereafter halogen family. So in halogen family, fluorine, chlorine, bromine and iodine. Fluorine, chlorine, bromine, iodine and astatine. So here astatine is a radioactive element. So these group elements are called halogens. Why? Because these elements are available in C materials, and NaCl again here very familiar example to us. This is available from we extracted from ocean water, which is very familiar to us. And fluorine is the highest electronegative element in this group, which is 4.0. So these all are more electronegative elements only. So then after these elements are having 7 electrons in its valency shell. Just you observe this electronic configuration. Each and every element having 7 electrons in its valency shell, means they are near to octets, so that's why they will show only one valency. So just you see these elements will form HCl, HF, HBr, this type of bonds only, this type of compounds only they will form. They never form HCl2, HCl3 like that they will form. They never form. Why? Because they will show every time its valency as a 1 only. So next group is inert gases or zero group elements. So that is helium, neon, argon, krypton, xenon and radon. These elements are called inert gases, noble gases, rare gases and ideal gases too. Why? Because why these group elements are called zero group elements, means they are not going to show, they are not willing to form any bond with any metal. Why? Because they already completed their duplet and their octet. Duplet means 2 electrons, which is followed by helium. Remaining elements having 8 electrons in its valence shell. For these elements no need to form any other bond.